So here's the DICOM file. As you know, this is just the very first step. And when you just get into the software, the very first module that you will see is the model editing module. Okay, so as you can all know, here on the top right portion of the screen, you will see the modules where we can change between the different ones that we have. Today specifically, we will work within the model editing, the advanced surgical guide, and the crown and bridge module. Okay, so let's say that we have this patient. He's partially edentulous, and we will do the planning for only here in tooth number 4. Okay, and for another webinar in another time, we'll also here show the nerve. How can, with the nerves, we can map the sinus floor. Okay, so we can later on do really interesting things here and use the Blue Sky Bio guided sinus lift kit, but that'll be completely another time. So for now, we have the DICOM file, okay, and we will import the maxillary model first. So here we're grabbing the maxilla, and we're just dragging it and dropping it inside of the Blue Sky Plan software. In this case, it was aligned, but the software will ask me if I would like to align the maxilla. Here, for example, I'll just click OK, and it will do an automatic alignment. This automatic alignment has been historically really good. So the alignment, when you import a scan, it will start importing the STL file into the CBCT. And if for some reason, when you actually trying to make your alignment and you have a result like this, that it's not going through, it's not aligning perfectly to the CBCT, what you can do is you can always go here in the model manipulation panel, okay? Go to the alignment, and then in the drop down, select align to teeth. And now, as always, you can just hold shift into the teeth, on the teeth that you would like to take as a reference. I usually get at least 7 points if possible. So here I am doing the same points on the model, holding shift and the left mouse button. Okay, so you can select the reference points. You don't have to be like super precise or in order. As long as you do the same points in the same teeth, then you just click align. You can use the functionality of the refine the best fit matching. The software will align that. And usually what I've been seeing on the software is that if you import your scans without a base, this will align well better than if you import a whole solid model, like in this case. Okay, so what this will be basically the best way to align. After we start aligning, we'll just click OK, and we will confirm that we have here now everything aligned. Okay, so let me really quick show the visibility toolbar for you guys to see, to be able to hide or show the different parts. So we go to view, toolbars, and visibility toolbar. So here now I can hide the nerves that it's going in the rooftop, in the sinus floor. Okay, and yeah, we have now an aligned model. We will confirm that it's completely aligned. I start here on my cross-sectional view. And please, if you want to ask something or to comment, feel free to do it. I will be showing a lot of information today, so that's why I jumped directly into the software. But please feel free to ask anything, okay? And if you can, Michael, if any of the questions, that would be great.
Sure. There's a question that just came in asking regarding it would be better for using in the incisal points for the alignment.
So the answer for this is, if you are using instead of teeth, if you're using the CT points, the model to CT points, aligning by points, then yes, it's more specific, right? But here, what we're doing when we're aligning by teeth is just basically correlating the coordinates of the model with the CBCT using the teeth. Is more a generalized surface matching. However, the aligning by points will be way more specific, okay? But what we're trying to do, first of all, is like, if you want to use a hierarchy, it will be first the automatic alignment, then the teeth alignment, then aligning by points. And then at the very end, if none of these work, then you can manual align. And for manual aligning, what I do is I confirm first the cross-sectional, then I check the cusp tips. Now here, when you are checking, you go now into the axial and you check the incisal edges, and then the cusp tips that you're showing here, the CBCT and the model. This will show that you have a very well aligned model. Okay, I don't know if I answered the question, but I have an idea. Okay, so now that we have the CBCT and the model, okay, usually what I do is I go into the 3D model view, okay, and I click the change volume rendering settings button, and I take away the rendering, because at this point in time, what I want to do is bring a wax up so I can start doing my prosthetic design, right? So here, what I'll do is I bring a tooth, so I will add a tooth. Then from the libraries, I always suggest to use any of the libraries that have a ovate cervical portion. Here, for example, I'm going to use a Mitchell's, a flat anatomy. Okay, and I will select the second premolar. Then with the left mouse button, you just click over the model, and you can see how it's almost perfectly positioned. You just move using the widget. Let me show for those of you who is just starting with the software. Every time that you bring any object into the blue sky plan, you will have this widget, which you will be able to rotate, okay, in any of the X, Y, and Z axes. It's very important that in order for you to move the object, you use like the perspective where you want to rotate it, and then rotate it, and this will give you control on the movement, okay? Also, you have the arrows where you can move them along the axis, and you have as well the, I'll say, the nodes where you can scale the object and change the size or the proportions of the object. Okay, so the way that I do my wax ups, and this is like in an everyday basis, what I do is I grab the model, I just position it in the first, I'll say in the position of that tooth, and then I start changing my views so I can position my tooth, okay, in the most clinically acceptable way or position. And once I have that, then you can always scale. So you can have like a true anatomic position of the tooth. The reason why I chose this library is, again, because it has a nice ovate pontic or ovate cervical portion that as soon as I add my implant and my titanium base, this will help to the software to create a nice emergence profile. I will show you that. Okay, so let's continue now. We have a nice wax up tooth, but let's say that we want to give it a occlusion. So we import the mandible. Okay, we import the lower jaw. Okay, we drag it and drop it into the software. And if you used an intraoral scan and models were related in occlusion, then you can just skip this part by Xing. And you can go into the model manipulation panel, select the new imported model, and then you will align to model. We will align the blue model, the mandible, the lower jaw model, to the green maxillary model, and then we'll just click OK. And these models are now aligned in the occlusion that the patient was taking that intraoral scanning. Okay, so this is something that can be used. Can you adjust the interproximal of the crown? Yes, you can adjust the interproximal of the crown. And when we are in the crown and bridge module, I will show you how to do it. Yeah, but the answer is yes, you can definitely change whatever the interproximal and the occlusal points and the occlusal surfaces. Okay, good. So now ones that we have now are wax up. Okay, if we want to check the occlusion, we could go and check the closeness in the crown and bridge module. I will definitely show you that as soon as we jump there. Okay, and now we'll start treatment planning our implant. We have now an acceptable wax up, and after we have the acceptable wax up, what we do is right click on the tooth. That's the way I add my implants. You right click on the tooth in any of the windows, in any of the views, and then you click align, and then align new implant. Once that we aligned to the new implant, we will go into the implant library, which by the way, now we have, I think that 4 or 5 or 5 new brands. So it's improving tremendously now. But in this case, we will use the Blue Sky Bio, the BioMax, which I think they're great implants. And in this case, we will go for the 4.3 by 10. Let's see if that will be suitable. I will always start with that implant, and then I can go from there to a narrower or shorter or longer and wider implant as the case is needed, right? Okay, so once that I selected my implant, the body of the implant and the platform here in the BioMax, we have always only the narrow platform, so we just need to change the width and the length. So here I will choose that, and again here in the top I have the abutment section. Okay, so for Blue Sky Bio users, you can go to select abutment, and you will have a list of abutments, which by the way, if any of you is or in contact or are representatives of a brand of an implant brand, and you can contact your sales reps and tell them to send the STL files to send to Blue Sky Plan the files for adding the libraries of abutments. And this will be, number one, they can be protected. And number two, they can totally be inside of the library for you to use this functionality. For now, we have the Blue Sky Bio, and we are increasing as well. And there are more libraries coming soon. Is that right, Michael? We have.
Yeah, definitely. We have, in terms of the implant parts, I think we have over 50 libraries now, and the prosthetics are growing rapidly. So we have a whole bunch of systems now, and we're adding the prosthetics parts for different systems on a weekly or bi-weekly basis. So, yeah.
Yeah, that'll be really interesting if your brands, if your implanted brand that you're using, they can get in touch with us. It will be really easy. It's a very, very efficient way to do it. Okay, so here we can change, we can choose the different titanium base that we will use. Here we have the regular is a 0.5, and then we have the 1.8. We have a mini and a narrow titanium base. As well, for those cases where you're doing anterior and you have a slight angulated part, we have an angled tie base, which works really good. So for this specific case, I will use the regular titanium base, and I'll just click OK. This will be for giving me a realistic experience when I am planning my implant. Okay. So the very next thing I do once that I import the implant inside of the software is I start positioning the implant in the tangential view by zooming in. You zoom in with the right mouse button, you press and hold, and you basically drag it forward or backwards. That's how you zoom in. So once that you have a zoomed view, the first thing I do is I select my implant. I center my position of the view position, and with the left mouse button, I move the implant. Always in the perspective that I am, I will try to have it in a clinically acceptable position. So here, for example, is not. So I am just moving the implant now. As well, I think 10 millimeters here is way too long. So I will replace that implant, the length. So I'll right click, I'm sorry. Okay, so now at this point in time, we've finished everything that we needed to do on the model editing panel, okay? So what we do now is we change modules. We go here from model editing, we change to advanced. And now here in advanced, what we do is we just right click on our implant, click replace. And now instead of 10 millimeters, you go for the 4.3 by 8. Then click OK. I think that's very acceptable. So now we will just position the implant. I like the Biomax to be about 1.5 millimeters subcrestally. So in order for me to know how much, I will grab the ruler and I'll just put my 1.5 so I can know exactly where my fixture head will be. I can even zoom in and confirm this. Okay, so now I have one implant that it's subcrestally positioned and that it's slightly away from the facial wall. So let me now check that I'm as well about 2 millimeters away from the roots. That's good. And also, I would say, yeah, I'm far away from, I'm comfortable now with this position of the implant, right? So once that you're comfortable with the implant position, now what you can do is, wait, somebody's asking something. Okay, so what you can do now is, I think, yeah, Leila, I think this will be saved. I don't know. I think.
Yeah, yeah.
Okay. By the way, hello. Okay, so now you can see that you have your implant, your titanium base, and the wax up crown that you're doing with the ovate shape. So this seems that it will work very well. This will not look, this will have an anatomic shape, and this will have an emergence profile, subcritical and critical contours that it will be ideal for us that we can create now a crown, right? Where we can 3D print this and use it with our patients. So we made it thanks to all the team and Michael that is leading that, we made it happen. How we now can go to the modules again here, and we can go to crown and bridge modules. Here in the crown and bridge module, what we will do is we will go to the restoration design panel. Here in the restoration design panel, we will start a maxillary crown on a tie base. Okay. Here you can check the occlusion or the closeness, if you want to call it like that, as the software names it. Here you can check the closeness of both models. For example, if I want to check how close or how or if it's impinging the model with the opposing, you can check between both models where it says closeness. You can just check how close is this, and it will tell you. You can even bring here the closeness between the opposing jaw and the mandibular crown, right? So, and here, of course, now these models, they don't have occlusion as in some points, but you can just check out the visibility, check out the closeness for everything, and wherever you have any point, it will turn here. As you can see with a heat map, it will show you with colors where is closing, where is actually close or impinging. Okay, good. So you can, and if there is anything that you need to change, then what you can do, you can go to the teeth edit panel, then select where it says active model. You will select the tooth that you want to edit. And here you will have a few different options or tools to use. Here you have the smooth, the global geometry transform, which I think that it's a very, very good tool. Okay, here you have 27 points where you can modify the shape of the crown, okay, without doing too much structural changes on the design. So it's really useful. Okay, and you have as well the local geometry transform. For those of you who are familiar with CEREC, it's just like the circular. Well, it's not just because it's not the same, but it definitely works as that for you as a user. Okay, and yeah, that's it. Once that you're happy with your design, what you can do now is go to the restoration design panel, select crown on the tie base, select the orientation of your models, and now here in the select models, you will select the maxilla. Here you will add your crown, the tie base, the opposing, right? And now you can start to use this crown. First thing will happen is that the software will bring you to the area where you can like add a crown. So let me show you the very first step. So this is a series of steps where the software, it's really straightforward, where the software will take you from step number 1 to the final step so you can create a crown. So here's a few questions. Let me just answer real quick. So here, this is an immediate implant. Yes, this will be an immediate implant. Okay, or this can be, this not necessarily need to be an immediate implant. This could be like implant where you can just place it. It can be an immediate placement, or you can place it so crestally, just let it slip. And by the time that you are uncovering, you can use the custom healing abutment to plan it. So it definitely here you can use it as you prefer. Okay, even you can even do, if you want, an extraction with using the model editing module, and then use an immediate placement. So clinically, yeah, the clinical procedure that you want to do, it totally doesn't matter. However, the fact that you can have the surgical guide and the custom healing abutment, the temporary and the models before you even touch the patient, that's something that it was not easy to reach a few years ago, right? So now showing these capabilities, you can totally explode and you can improve everything that you know clinically. Okay, good. So what we do now, the very first step, this will create the insertion path of the crown. In this case, what I like to do is I like to get this green screw channel right in the center. And I also take in consideration the adjacent interproximal surfaces, okay? Once that I have this view in the window, I will click where it says set insert direction from view. Once that I have done, once that I do this, the software will automatically create that path of insertion. I can change it if I want to manually as well. For you that you have been using as well, the denture module is exactly the same thing. Okay, if you want to change it, you can change it manually, or you can, again, this is what I do. So far it's good. I click set insert direction from view, and then I click next, which is this chevron-like arrows. And this will take us to create an undercut model, okay? So once that you have created this undercut model, and the reason why I create the undercut model now, or here for the crown and bridge, is because I want to create, before of everything, I want to see if the crown that I'm creating, it looks like a clinically acceptable crown. Okay, so that's why I create my temporary or my crown and emergence profile before the surgical guide. Because if I want to change anything on the implant or the restoration, I can do it again and just go back and forth in the surgical and crown and bridge module until I am happy with that. So good. Now on the second step of the process, what I have to do is I need to check the interproximal surfaces so the software can automatically place an anatomical tooth. So we can do this by holding shift and just with the left mouse button painting on the interproximal surfaces of the adjacent teeth. If you want to add these points, we'll hold shift and the left mouse button. And then if we want to erase, for example, here's too long, the interproximal surface, with the control and the left mouse button, I will be able to delete this. Again, shift and left mouse button will add, and then control and left mouse button will erase. Okay, good. So I painted now my interproximal surfaces. I can even select as do not modify the crown shape or placement. Okay, and now you can go to the next step. Once that I have this, the software is calculating the shape of the tooth. And now we have the crown plan. Now what we're doing is our emergence profile. Okay, so how the crown will emerge from the soft tissue. So here we have a margin, and we can start. I always like to start by using the project margin function. This gives me a nice ideal. Well, now it didn't, but usually it does a very good job. However, what you can do now is that you have, what I do is I check where is my emergence profile of the adjacent teeth. And what I do is I just hold shift and change, hold shift and with the left mouse button, create my margin or my emergence profile margin where I can, where my crown will be emerging from the soft tissues. Okay, good. So now we can just paint if you want to call it like that, we can paint the emergence profile. Okay, here, if you would like to have the crown or the tooth just as a reference, you can go to the teeth surfaces, and then where it's visible, you can just click on the visibility of the wax up tooth. So you can check if this is what you want. Okay, so we go back to restoration design, and with the left mouse button, I'm just drawing the emergence profile. Here, I do want some thickness. I do want some color thickness, so I definitely want some space in these areas. And now, here, I'm just copying the emergence of my restoration. Okay, so this is good. Okay, perfect. Once that I have one emergence profile that I'm comfortable with, so what I do is I just click next again with these chevron-like line arrows. And now this will be taking me to the next step, which is the subcritical and the critical contours, basically the shape of the abutment area. Okay, good. So here, what I'm looking for, okay. So first of all, if you're asking why is this red color here, is because we had in the surfaces, we had the closeness functionality on, so we can always just deactivate them if that, if we're bothered by that. Okay, so here in the restoration design panel, we will be able to have now our emergence profile. Okay, so what I'm looking for here is I can have these nodes and I can change them. I can change the shape of them. Okay, so I can have these areas that I like to have concave under the soft tissues, and as soon as we're emerging, then we can change them to convex. Okay, so we want now a flat, or I would like to say concave surface. Okay, and we can just with the left mouse button and very small movements, we can change here to have a nice concave shape in here. Okay, so once that we have that created, what we do is we use here the crown margin refers to the part. Look at this. So we have here the yellow emergence profile and the crown, right? So as soon as I modify the tab, this will change the shape of how the abutment and the crown, they actually stay together. Okay, so what I want to do is I want to have a seamless integration here between the crown and the abutment or the emergence profile. So here I have a seamless shape. So I don't want any steps or any edges. We want very smooth surfaces, very smooth changes. So we have now the crown margin. Okay, again, you can see how the surface, it looks really smooth change between the crown and the emergence profile. Good. So we'll do now the same thing, but now with the crown, I'm sorry, with the emergence profile on the titanium base. Okay, so here we slide the bar. So we see here this seamless change. Okay, this seamless margin, if you want to call it like that. And now we're ready to go to the next step. If there is any question, it would be really good now to ask. There is no way to standardizing. So here's asking if there is any way to standardize like a concave degree. However, you can, it's really easy to see what you're doing by just looking at the profiles Okay. And to be honest with you, there will be always like changes between the cases. So far, and I do this like in an everyday basis, so far I have not seen yet like a pattern where I can say this is exactly the concave surface that I would like for all of my implants. Sometimes it's flat, sometimes it's slightly concave, sometimes it's very concave. I mean, I would love if any of you would like to start researching about that. That would be really interesting to know. Okay, but for now we have this, like we can manually change this. Okay, good. You can do as well the minimum thickness. So for example, if you will 3D print the crown, there are a few, I will not say a few anymore. There are a very good armamentarium of materials that with at least 0.5 or 0.4 of minimum thickness, this will give you very good strength or resistance in the material. Okay, I've been using the Vigo crown. It smells really good. Okay, and the Accurata printer. Okay, so now you can do the crown cement spacer. You can select it. I do like the 0.1. They are tight, so I really want that. And you can, if you want to create like a cemented retain restoration for some reason, you can uncheck this, and this will not create a screw channel. However, if you would like, as 99% of the cases that I do, a screw retain restoration with a screw channel, you can just click that and this will create a screw channel for it. Okay. Once again, we click next or the chevron-like arrows. It's starting to make all the calculations, and now we have, I'll say, the 80% of the crown ready. And what we will do now after this step is changing the shape of the clinical crown. Okay. So here, for example, I will do my, remember that I changed the contacts in the very beginning. So this is the shape that the software provided at the end. Okay, so so now it will be a good time to just design. I'll use the local deform tool. And I will just change my interproximal surface to create a nice interproximal area. Okay, a nice contact area. Okay, good. Here it's, well, actually this is important. This is very good that happened. Okay, because now I can show you how I designed the crowns. So basically here with the local deform tool, holding shift, you will have this tool that with the mouse wheel button, if you drag it back, it will change the size to smaller. If you drag it forward, if you scroll it forward, it will increase the size of the tool. And the way that I do it is I just zoom to the area that I want to change, make a general area, and just increase the size, very, very small increments. Okay, so here, for example, I would like to add, it's important to mention that even though I move everything, the internal portions of my crown will not change. And here I want now to create my contact area. Okay, good. So I have now this, I have now the shape of my crown. This will be like a ballparking, like a shape of a crown. You will be, I'm pretty sure that you all will be able to do nicer designs. This is just like a demo. And of course, here will be really interesting if we have occlusion. Okay, we could change, here is where we can change the occlusion on our case. Okay, so once that we finished changing the shape, the anatomy of our restoration, for example, here I want to make a smoother part. Here is this stop for the anti-rotational portion of the tie base. So I would like to smooth this area, and I can just smooth. Again, scrolling my mouse wheel button forward and backward will change the size. And if you use the tool strength, I really like the maximum strength. You can just make this smoother every time. So if there was any ledge whatsoever, now you are changing the perspective, changing the perspective and smoothing it, and this will be the way to have your restoration. Okay, so if there is any question so far now, it will be really interesting because as soon as we finish this, we'll go to the creation of the custom healing abutment. So I really need all of you to be paying attention for this. Okay, so once that we have this area smooth, can you save this pattern of the subcritical contour to make custom healing abutment for it? Yes, exactly. This is how you do it. That's a great question. Okay, so for example, now I will just smooth the interproximal surfaces. I don't really take a long time doing this step. The reason is because the software will automatically cut the interproximal areas that they are impinging. Okay, so any part that it's out or that it's impinging, the software will automatically trim it. Okay, so even though I create like a very, very wide area that it's completely out. For example, here it's too much, so I'll just undo. Okay, but there you go. This is too much. So if I would like to create here like a wider and it's impinging, I exaggerated that. I will just click next, again in the chevron-like arrows, and the software will cut proximal intersections for me, and that's it. You can just look that. Okay, so now we can go to the teeth surfaces and we'll have two different designs. Okay, we'll have one design that is my initial wax up and then your crown. Okay, so I do have now a crown that it has a hole. It's a screw retain restoration. Okay, and you can now, let's do now the custom healing abutment. Okay, so for the custom healing abutment, this will be really quick, really easy. You can just go here to the teeth edit panel. And then here in the teeth edit panel, first active model, I'll choose the D. D stands for designed. So it will be the design maxillary custom crown. Then here on the second area, we have the Boolean operations. Here in the Boolean operations, we'll select the different Boolean functions that we have. We have union, intersection, or difference, right? Union will join two surfaces together. Intersection will just preserve the whatever it's impinging between both STL or both objects, and the difference will delete whatever is impinging between both objects. Okay, so in this case, we'll use the intersection between the maxilla and my design maxillary crown, or here you can use the maxillary crown and the maxilla, whatever the order is exact in this case. Okay, I don't want an offset now. The offset will just be creating a larger, okay, a positive offset on the second molar, on the second model, right? So we'll apply this, but in this case, I'll just keep the offset in 0. So I'll just click apply. And if everything is good, I should go now to the teeth surfaces and I'm gonna hide my green model or my maxillary model. I'm gonna hide my first, okay, the way that the software position all these design surfaces is from larger to very small, to the smallest, okay? So I will use the first one and I will just click out the visibility of it. And then I have a series of all these small surfaces that they were impinging with the green model. Okay, so as you can see, we have now our custom healing abutment. And then we have here all these small parts that are not relevant for our design. So we can just delete all of them. Okay, there you go. So now we have only our custom emergence profile, abutment, custom emergent abutment, custom healing abutment, sorry, and our temporary crown. Okay, which, as you can see, as you asked me, Mohammed, you asked me before that, yes, you can save the shape of your emergence profile for your final crown. Okay, good. So now what we will do is, I think that this looks really good. Okay, this could be something that I could use in my mouth or any of my patients' mouth, or I can send it into La Pronto to any of the doctors. And now we can just go and change from the modules and change to advanced. Okay, because now I'm happy with the design of my crown. I want to see it in the 2D views. So I will just check 360 degrees of my restoration with my crown and my implant. And now that I'm happy with this, I will just, sorry, I'm going to go to the surface panel, visibility on of my green maxillary model. And now let's start to do all of the surgical planning. Okay. So now what we will do is we'll hide all my teeth surfaces by clicking on the visibility toolbar. So I can just have my implant and my titanium base. And now I can go into the implant list. So you can go into panels, implant list panel. Okay, and I will start with the way that there's like a ton of ways of doing implant planning. The way that I'll do it, the way that I'll do it is just like first starting with the ID of my tooth, clicking the visibility on. Okay, let me answer some questions now that they're coming. Sorry about that. The custom healing abutment will be printed in one piece. Oh, I'm going to show you that. Yeah, let me finish the surgical guide. So now what we have first is the ID of the ID number. In this case, for example, we could do 1 or we could do 4 or 5 restorations, right? So for demonstration purposes only, in this case, I am going to do only this. So first I put my ID, then I scroll 360 degrees, check my implant again. I do this all the time. Once that I'm really sure that my implant is in the accurate position that I want it, and then that I decide that it's okay, I'll lock it by either clicking here on the implant list panel. You have the lock functionality where you can click on or off. When the lock is not checked, I can change the orientation of my implant. Okay, and when I have that locked, even if I try, I cannot move any my implant or my abutment. Okay, so once that I'm happy with the position of my implant, I lock it. Then the very next thing I do is I select the drill kit. So for example, here we're using the Blue Sky Bio fully guided keyless kit. Again, if you're using any brand of implants and you have a guided implant surgical kit and you want to add it here, just speak with your rep and just tell them to add the libraries to Blue Sky plan. And we're really accessible when it comes to that. We're really accepting, or Michael mostly, he's accepting all of the implants and the libraries. And yeah, we're as long as the companies they just agree to send the files, we're more than happy to add them into the software. Okay, good. So What we do now is we select the surgical kit here on the tubes. Here you will see the brown tube, right? And then you can just click on so you can see this brown guide tube. This brown guide tube will be the resin hole that will be in your surgical guide, okay? And well, for you guys, so if for some reason you're doing surgical guides and your sleeves, they fit really, really tight when you're placing them, this webinar will be good for you because now you can go, now I will show you how to make this, this hole or the guide to space to be loose enough or perfect for your sleeves to fit in, okay? So you can always go into tools, preferences, and then where it says surgical guide, and then software guide tube distance. By default, it comes always into 0.1, okay? However, you can calibrate your resin. For example, in my 3D printer, I use usually 0.20, okay? There's a ton of changes. There's a ton of different settings that you can do. However, if you, the way that I do it is I just grab a surgical guide, I 3D print a few different ones with a 0.1 in change or even 0.05 and in increments. And when I see my sleeve that it's going, that it's fitting like very good, that's where I use it. And in one of my printers 0.20, and then in another of my printers that I use the form, the 3B, it's 0.15. The accuracy is impressively good, and you can use even a 0.15 as well. Okay, so yeah, this will be my settings. So and every time that you change, you can see here in the guide hole diameter that it will be changing the size of this brown tube, okay? And this will create the right space for you to slide in your sleeves. Perfect. So now what we do is we check here on the tangential view. So I will enlarge my tangential view, I'll maximize that window, and I'll check that I don't have, or that I have at least the least amount of brown tube impinging inside of the green model, okay? So basically, you don't want your surgical guide to be impinging on the soft tissue, because what will happen is that the guide will not fit perfectly. So what we do, like in this case, we can just right click. If for some reason is impinging, you can right click on your implant, software guide to raise. And then when you raise it, it will jump. Let me do it again. Let me click reset. So here, the offset of the surgical guide, of the fully guided keyless kit is 8 millimeters. And here I need to increase the length. So what I do is I right click, software guide tube, and raise, and this will jump automatically into the very next drill. So for example, now it's an 8, software guide tube, raise, and now it's in 13, but it's because I've been increasing. So I can just go again here into software guide tube, default settings, and it will go to the very next drill, which will be now in this case 10. So the final drill, instead of being the 8 millimeter implant, you will use it 10 millimeter drill, even though you're placing an 8 millimeter implant. Okay, and so on and so forth. Good. So now what we do is we check again 360 degrees of the guide tube that it's not impinging. Minimize the window, and now everything that we need to do now is the surgical guide. Okay, so we maximize the 3D view. we go to the guide panel. Okay, and now for this version, the 4.8, we still need to create an undercut model and a path of insertion manually. However, this was a change that the people was asking to make it automatically. So for the newer versions, I don't know in which point in time are you looking at this webinar, but today, in May the 2nd, the 2021, we will have to create an insertion direction. So we click here, define insertion direction. Okay. In my computer, I have the insertion direction at 0 degrees. Okay. However, you can always change the insertion direction by moving manually the insertion direction of your models. Okay. Or you can just select, position your model, sorry, in the way that you will insert your surgical guide. Okay, so let's say your surgical guide will be inserted using this path, and you can click like define insertion direction from view. Okay, or again, just reset to 0. That's, to be honest with you, that's my my preferred method of doing the surgical guides, just using the default insertion direction at 0 degrees now. And once that I have that, I will just check the maximum allowed undercut is 0, because I'm doing a tooth supported guide. So I don't need really to be tight. I don't want any undercuts because I want the guide to seat. Okay. So now what I'm going to do is I will create my undercut model. Now would be a very good time for questions if you have any. Good. So now we have our undercut model. Okay. So the very next step to do is our windows. So I want to have a visual confirmation that my surgical guide is seating all the way into my model. Okay, or into the teeth. So what I do now is I right click on the undercut model, click add window, and I'll use something that I really like to do is I grab my window, right click, increase transparency 25%. And this way I can see how much of my teeth are being covered by the window. This window will create a hole in the guide. Okay. So here we can just enlarge the surface where my window will be. Once that I have that, I can start creating my surgical guide. Okay. Once that I have this area, I just protrude it through the facial. And that's it. Now I can start planning my surgical guide. So I can draw the curve, the outline. So here where it's a surgical guide, I'll just click draw curve and I'll do my surgical guide. So I hold shift, you'll see the mouse cursor will change from a pointer to a cross. This cross, hold shift and left mouse button, and I will draw a line, or I can make like single clicks. That will totally depend on you, how you want to do it. So change the perspective and create your outline. This will be a good outline. I really don't want to cover all these palatal surfaces because then it becomes too bulky. And all the resistance of my surgical guide is given to the material thickness and the curve that I'm allowing here to have between the arch. Okay, so this will give stability and rigidity, so it'll be good. Okay, so now next thing I do is I grab these points and I just put them close to the guide tube. If for some reason, for any reason, you would like to do like this cooling like these coolant holes in your in your surgical guide, what you can do is you can add a window. Okay, and you can create like a very narrow area, like a very narrow window, make it protrude, and you can just position it within the long axis of the implant below the guide tube. So after you position the sleeve, you can create two holes. One hole will be for injecting water and the other hole will be for positioning the suction. So you can create like a flow, and that's it. Okay, so, and as well, if you need any guiding for the timing of your implant, you can as well use Windows. There's a ton of that. I could make a webinar on how to use Windows of 1 hour and doing this. Okay, so what you can do now is you position the windows that you want. This will be basically planning the holes that you want in your surgical guide. Then you click create surgical guide. Okay, and after we do this, we customize our surgical guide. We will create a set of articulated models, export, and then and that's it. Okay, so I think that maybe in about 15 minutes we'll be ready. Thank you all for the time. I know that now it's more than an hour, but I hope that this is being helpful for you all. Okay, any questions so far? Is there any reason, Renee is asking something. Is there any reason why the guide will not fit into the model? Yes, and that's an excellent question. So, and actually let me create an error, okay? So, but wait, Renee, I'm gonna answer that question in about like 5 minutes as soon as I finish the whole work, but yes, there is a reason why this guide will not fit, and the reason will be because the insertion direction, let me go to the surfaces panel, check out the visibility of the window, and go back into the guide panel. Okay, good. So here, let me hide my implant first. So here, you can see that the Undercut model created these areas like a digital surveyor, okay, that will create a path of draw, will create a path of insertion. For any reason, if you don't create this in a way that you can see that this is expulsive, okay, let me show these. So if we have any retention and we don't create the insertion direction according like or in a good way, and we create an undercut, then what will happen is that the surgical guide will fit in one area, but will not fit in the second one. So it will not be easy for you to insert that surgical guide. Okay, or even worse, if you do not create an undercut model on these a version of the software, this will create undercuts that will not allow the surgical guide to go in. As well, you can go into tools and then preferences. If for any reason now you're having problems with the guides not fitting, where it's again tools, preferences, surgical guide, defaults, insertion, path, direction, just click 0, and this will solve all your problems. Okay, then you define insertion direction, reset because I modified it all around. But so define insertion direction, create undercut model, and these will, I can almost guarantee that this will fit 90% of your cases. Okay, I hope that I answered that question. Okay, good. So now what we'll do is I deactivate. This is really important what just happened now. If I have the tool activated, right, and I start changing or I want to do any other thing, Until I don't come to the guide panel and I deactivate the tool, I will not be able to proceed. Okay. So what I need to do now is I need to customize my surgical guide. So I'll grab my guide. Oh, by the way, here is a cooling hole. So I'll grab my surgical guide in the guide panel and I will just name it. This will be, for example, number 4. Oops, here, number 4 for patient John Doe. Okay, I can emboss it using the software. Oh, sorry. I need to here select first the model, and then show label, and then emboss and add text. So this will create like the text out of the surgical guide, okay? And you can also use, for example, in this case, we're using an 8mm implant, right? So this will be an 8mm implant. And it's a 4.3 by 8. So it's 4.3 by 8mm implant. So here we can just grab this. And now we can engrave it. Let's see how it engraves. So engrave is basically the text inside of the object. Okay. This is the reason why I do like more the embossing is because it's way faster. But this one, and it's easier to read, but this is embossing, is really cool. So if you use it, this is really functional. So now there's a ton of guides or that I see that usually you put the label. So let me now put, this will be the implant. But now, if you remembered, we changed the offset, right? We changed the offset to a 10mm. So I need to remember that. So I will just group here 10 offset. So I'll grab this and now I can change the size of the embossing by zooming in or out my model. So here, this is one of the most important things because the 10 offset means that I'll use a 10mm drill and the 10 mark on my guided driver. So that's really important. Okay, good. So I use a 10 offset. I can emboss it. Usually when I emboss my guides, I use a Sharpie and I just pass it through the letters so I can read. And I have here, for example, 10 offset, name of the patient, tooth that I'm doing, the size of my implant, and if any, the offset of my guide. I have windows, I have cooling. Sorry, I really forgot the name of it in English, in proper English, but this is the cooling areas where you can inject water or cooling saline, and you can use a suction here as well, so you can create a flow. And well, you're good to go. So now in the planning, everything is really good and looks good, but I don't know when exactly I will have my surgery, right? So I will come back into the planning and I remember that I placed some measurements. I don't know where they are, but no worries. So what we're gonna do is I will use the measurement. I will, okay, here they are. Here are my, my limits. So I'll grab these notes. I can just change this here so I can know exactly what is each of these measurements. Again, here with a ruler, I'll measure this and I will take a snapshot. So here, a screenshot. So here on the camera, save screenshot. This will be my very first, oops, sorry. Okay, here, screenshot. And this will be my very first screenshot. I change the perspective so I can see the buccolingual. And I will grab the ruler again. check all my measurements. Here, for example, you have to know something. If for some reason, these, for example, these in the Biomax, okay, we know that this area is part of the active design of the implant, right? However, the real, it's not the real, what the osteotomy will look like following the body of your implant, okay? So you can make all these measurements, but you have to take that in consideration like every time, okay? Here. There you go. So you position all the measurements on their side, take another screenshot, save it. If you want for to just make any like mental notes of what you're doing, you can position the name of the patient and the tooth number, the implant that you're using on the guide, okay, and the offset. That's something that I do this like systematically, okay, because I think that they're really important facts for a surgery to be. So let me answer some questions that they're doing now. How do you print the model to try in? We'll go for that now. Always rise a surgical guide, entire tooth. Yes, I do the surgical guide. Thank you, Yona, for your question. I do plan the surgical guide exactly on the CJ or the maximum coverage that I can do. The software will automatically create that draw so the guide fits, but I do plan up to the CEJ. So I do a full coverage. Okay. Good. Okay. So basically that's like my drill report. So what I'll do now is I'll click here where it says drill report. Again, after the screenshots, drill report, or you can always go to file and then drill report. And this will take you directly to this area, or you can just go and click PDF. And then here in PDF, you will see the patient name, the date that you're doing the planning, the project name, the drill kit, manufacturer. Here, for example, using the Blue Sky Bio kit, you have the code of your implant, okay? You have as well the implant height, the amount of drills that you'll be using for the surgery, the sleeve that you have to purchase in order for use your kit, okay? As well, you have the abutment that you can purchase, 0 degrees in this case. And this is the sequence that you will be using. And here will be all the information that you need. Usually what I do is I 3D print this, not 3D print, sorry. I print this page and I save everything else as a PDF and I just save it into the records, okay? So once that I have that, I just click save and I go into the folder where I have my patient, okay? And I save this as type as webinar, whatever name of the patient is, and then click okay. And now you have a drill report. So another thing to do, so that the very next thing to do will be, okay, now I have my surgical guide, okay? And I want to create my models. So I can always go here to model manipulation, and then I'll create an articulated model if you want to. So here I'll use my maxillary model and I use my mandibular model as lower, and I'll add the pins. So here, this is a really, I think that this is one of the coolest things that the software has. The most useful thing that I use for cases. You can use the pin models, okay? And these are articulated. These are great for dentures, great for full arch cases, for edentulous patients. There's so much functionality. So you have these bars, you have these posts where you can select them and change the position of them, okay? And you can move in such a way that you can predict how are all the posts going to be and how are the pins will articulate your model. Great. So you double click on the post, you move it. If there is some portion of the bars that are impinging, you can always change the position of them, or you can just change the position of your posts, and that's it. As well, you can change the thickness of the bars that they are joining, that they are putting together the model with the pin, with the posts. There you go. And also for creating like just like an anti-rotational, if you want to call it, you can shape as well. You can scale the shape of these posts. Okay, so once that you're ready, you can just go again into the model manipulation panel, create articulation pins, and this will create an articulated model. Okay, so once that we have our model, we'll go to the export phase, which I think that is what everybody's asking, how to do the custom healing abutment and how to do the crown. So the way that I do it, it's really a workaround that because a doctor was asking me that he wanted to create this crown or this custom healing abutment but he didn't want it to trim all the titanium base that it was protruding through the gingiva, right? So I started to think about exporting the tie base as an STL file, re-importing it, and then going directly to the fixture. Okay, so I will show you how to do it, but let me first finish with the model. So I have these two models that are with pins, so you can articulate them. But let's say that you want to customize them. So again, you can go to the text tool. The text tool is located in the guide panel. So you go here into the guide panel, you name John Doe, and then you can emboss or engrave whatever you want in the model. So here, for example, you go into the model, you select the maxilla with pins, and you engrave. I do like engraving in the model, so here I just engrave this, apply text, and you can customize your models as you wish. Okay, good. So now we have models, now we have crowns, and we have the custom healing abutments. Let me just export this titanium base as an STL file. So let me go to File, Export Data. I will just export the things that I want. In this case, I want just export the abutment. So here I go implant. In the implant list, I will unselect the implant. I'll unselect the guide tubes, and I will just have selected these export abutments. I click now export. Again, if you see this, as long as I'm not exporting a model after I created an implant or a surgical guide, okay, the cost will be completely zero. So here, for example, now I'll export the abutment, and here I'll just export this. There's a warning saying that the files will be overwritten. It's fine. And now I'll go to the folder where I have this case, and I have already a tie base. Okay, so I have a tie base model. I'm sorry, I have the abutment. So I'll just drag the abutment STL and drop it inside of the plan of the Blue Sky Plan software. And now here, you don't need alignment. So you can just exit out because it has already the coordinates of my implants. right? So here I can hide my maxillary implant, and I have an STL of my titanium base. Also, I have an STL. Let me go to the tooth list. I have an STL of my custom emergence profile. I have an STL of my screw retain restoration. Can these be for a temporary? I don't know, but for sure, yes, these can be as one piece custom healing abutment that you can screw retain, and as long as it doesn't have any function, it should work. So far is going great. I cannot recommend it as a proven thing. It's just being total case of one, but so far it's doing great. Okay. Now we can go to file. Let me just start showing you all how to export the file so you can get the results you want. So you can go to files, export data, and here first of all, I'll start exporting the surgical guide, the models, and that's it. So first, let's just choose the things that we want to export. I want to choose now only the models and the surgical guide with windows. That's it. So I'll choose all of them, and I'll make sure that I have this export separated files to a folder box marked. Again, if in this version, specifically in this version, you have the capability of export a file format, and you have here a drop-down menu between OBJ and STL. So here I'll just choose STL. The quality, I do like the high quality. It's just more triangles. It's good. And I'll just click export. And this will give me a single STL file for each of the files that I'm exporting. So I'm going to go to the folder, and here I have one mandible. Sorry, here. Okay, we have now the maxilla with pins, which will be, let me just take it to the, oops. I'm going to take it to the printer. I'm going to use the slicer just to position it. Okay. So here I'll use the frozen shuffle Excel. And let's see what we have here. So far we have the mandibular model, the surgical guide, and the maxillary model, right? Good. So let's now go back to Blue Sky Plan, and let's go to File, Export Data, and let's just choose our abutment. And this is the STL, this is the file, the BP1, okay? This BP1, the maxillary custom crown BP1, it would be great if we could just rename this, but anyway, we can just go File, Export Data, and is the very last one, okay? We select this file, we select as well the abutment, but in this time, in this case, we will uncheck the separated files to a folder option. Why? Because we want them to be together. So we export that part. We'll call this custom healing abutment. And now, why not? Let's just export another one that will be the temporary crown with the abutment. Why not? Let's try going directly to the fixture now. This will be called temporary direct to fixture. And let's say that we would like to mill this on Emacs or Zirconia or whatever. We can just choose the crown, and as well, we can choose the CAM XML file. This XML file is basically the path or the coordinates or all the instructions that your milling unit will need in order for milling that specific crown and fits well, and it doesn't break, and it doesn't chips out the materials. So once that you have the XML and the crown, the restoration, these will be automatically selected, the separated files, and then you just click export. Okay, yeah. And now let's see what we have in the folder, right? So now in the folder, we have the construction file. This is the XML file that I was talking about. We have the crown that is a screw retain restoration. We have the crown direct to fixture, and we have the custom healing abutment. Let's see how they look like when we're taking it into the slicer. So we're just dragging them and drop them. And now we have here, let's see. Okay, so we have now one healing abutment that it will be directly to the fixture. As you can see, it even has a screw the threads. I mean, don't get me wrong. These will not be perfectly printed on the threads. However, you can grab an analog, okay, and you can grab a screw, and you can just screw down that custom healing abutment to the analog and perform or self tap that area. Again, this will not be used as a restoration. This will be just used to conform the tissues. You have here the crown that you can mill or print or do whatever you want with that. And here is a temporary that you can 3D print or manufacture. And well, basically, that's all about, that's everything that I wanted to show you. This is all that we did. We're doing the surgical guide, we're doing the models, we're doing the restorations. So let me now check the, if you have any other questions, I'll be happy to answer. Again, if you want to use some of these features, but for some reason you're in a bad experience with the software, or you don't have the time to plan yourself, there's always a chance of using the Lab Pronto. Actually, in all my courses, I lecture about that as an integral part of your digital workflow. Really, I think that has been a very good company that Michael created with the Lab Pronto to be able for you to outsource. For example, here in Lab Pronto, if you want the surgical guides, you can outsource basically everything from the planning, the printing, or the full process. You can do fully edentulous cases. Let me just show you real quick here, the Lab Pronto, the website. So if you want here you can select from surgical guides, from aligners, like all the restoration, dentures, and you can also have the training and education for the software. And here in the surgical guides, what I want to show you is that you can, in Lab Pronto, you just log in. This will be, if you've never created a user, it's really efficient. You can just either log in with Google or register a new account, right? And then you can choose between designing, printing, or creating the whole designing and guide fabrication. And then it will take you to a series of steps where it will be like creating a very precise prescription. You will upload your CBCT file, upload your STL file, or your Blue Sky Bio design file. So let's say that you're already planned the model and the CBCT or your implant position if you want to control more. And then you can have like basically all those steps from the very beginning to the end, like controlled. And after the designer claims, the lab or the doctors, they claim the job for this, they will send it to you for approval. And that's basically it. Okay. So I think that it was a lot. And And yeah, if there is any question, Michael, you want something?
You want to, do you have time for another question or two? See what people posted
Yeah.
and respond to that?
Yeah. So let me check. Here, here's asking, can we have a seminar in the future for material options and printed guided temporaries? Yeah, we can. Edentulous cases, how do we add pins and how many should be added through and through? Okay, so for the pins, I mean, this webinar was for single. However, so let's say that I want to add a pin in this case. I will go into the add implant. And here on the add implant, on the very end, you see pins. These are bone fixation pins. Again, if you have, we have different systems. Okay. I do like the Blue Sky Bio ones because they are really rounded on the end. So when you're putting the pins, sometimes you're looking for the right place. And if you have a very pointy pin, it will create some trauma in there. So, but yeah, you just grab the pins and you position it where you want it. And then I usually don't go through and through with the pins. I go 3 to 5 millimeters inside of the bone, position it, just change the orientation, and that's it. That's how I position my pins. Okay. Well, I think that's it. There's a ton of questions regarding the healing abutments. So yeah, you're planning the abutment and a crown. You standardize no. Well, if there is anything else, I'll be happy to answer. And can you do the healing abutment without designing the crown? You know what, Brian? Even though you could, by using just the anatomy tooth that you're bringing in, yes, you can do that. Actually, I am now, I'm finishing, I hope that it will be soon in the libraries. I'm finishing a teeth library that will have the emergence profile, that is basically all the teeth with the tie bases. And actually it was what we were talking about in the beginning. They're like ideal fluted shape emergence profile. So probably with that library, that will work. At this point in time, it's necessary to create a tooth, I'm sorry, a crown in the crown and bridge module and do it. But to be honest with you, if you're just doing the custom healing abutment, what you can do is, you don't even need to take care of the clinical crown. So you can just click next, next, next until you get to the margin, and that's it. No? Okay.
Okay, yeah. So I'd like to point out that Dr. Raymond Rophie is scheduled in around 2 weeks to be giving a follow-up webinar presentation. He'll be discussing denture fabrication in Blue Sky Plan software. So if you haven't yet registered for that presentation, go ahead and do so, blueskyplan.com/webinars 2021. And you can also see the upcoming schedule for additional presentations as well. We also have links there to past presentations. So if you missed any presentation or part of it, you could go ahead and watch the recording for that. And as I mentioned at the beginning, we'll be sending the CE credits in around within a few days to your email. So look out for those. Raymond, thank you so much for the presentation. Thank you for your continual contribution and help and everything that you do regarding the software and assistance and explanation of a lot of things to me. It's very much appreciated. Thank you very much.
Thank you guys.
And thanks to everybody for attending. We hope to see you at future presentations as well. Enjoy the rest of your weekend.
Yep, enjoy and thank you. Bye-bye.
Thank you, Raymond. Thank you.
Bye-bye.
Bye-bye.